These are the video notes for lesson 4.1 to 4.4. Okay, in this lesson we are solving equations, and this one has a variable and number on either side. So there are two things that you should do. The first thing that I do is I bring over the smaller term that is attached to the variable. So we have the two terms 5x and 8x. I bring over the 5x because it's smaller. What this will do is it will almost always prevent negatives from happening until the very end of your answer if there is one. So you can bring over the 8x, you're just going to end up with a negative. So I'm just trying to prevent you from having to deal with a negative if you don't need to. So my trick or my key here is to bring over the smaller variable, so that's 5x. So what we're going to do is we're going to do the opposite sign. 5 is positive, so I'm going to put a negative here, which is going to serve as a minus sign. And I'm going to put it underneath both. So what I've essentially done is I got rid of the variable on the left, and I made the variable go on the right side. Obviously, 8 minus 5 is 3x. I'm not going to write that just yet. So because the variable went on the right side, I'm going to put all my numbers on the left side. So that plus 6 needs to be brought over, and I do that at the same time. And so the 6 will go to 0. I should have written 0 here. You can just cross it out without writing the 0, but just for extra clarification. So you'll get negative 9 is equal to 3x. Then I'm going to divide both sides by 3, and negative 3 is equal to x. So if you subtract 8x, you'll end up with negative 3x, and it's just one extra step you have to deal with. And this strategy of solving it this way will be very helpful when we encounter inequality equations, which is coming up. Okay, so the next one, negative 2x is smaller, so I'm going to bring that over. So now all my variables are on the left side, so I have to make sure to bring the number to the right side. So I'm going to add 3, and this will be 6x equals negative 6. Divide both sides by 6. X is equal to negative 1. You should cross these out to indicate that they do become 0, so make sure you cross them out. Okay, try these examples. I'm going to add 3x. Subtract 3, negative 15 equals 8x, divide both sides by 8, negative 15 over 8 is equal to x. In the next example, I have to distribute, so 12x plus 21, and then I can use the strategy, which is bring over the smaller term, and then bring the numbers to the other side. This goes away, so that's going to be 10x equals negative 26, divide both sides by 10, and then reduce the fraction. Make sure you always reduce, and that's negative 13 over 5. Okay, the next lesson we have some fractions with the equations. So what I'm going to do is I'm going to multiply by the LCM. There are 4 denominators, 3, 1, 1, and 6. Recall that whole numbers have denominators of 1. So if you want to put over 1 for the 4 and the 5x, you can. So the LCM is going to be 6. And I'm going to take this 6 and multiply everything in the bracket. So some side work, 2/3 times 6 is going to be 4. 3 goes to 6 twice, and that's going to get us a 4. So this is going to be 4x minus 24 equals 30x plus 5. And then 5, 6 times 6 is 5. If you have trouble with multiplying fractions, please go back to the original video where I taught multiplying fractions. So what's awesome about this method is that when you multiply by the LCM, all the fractions disappear, and the equation is much more solvable. So I'm going to subtract 4x, and then subtract 5. Again, negative 29 is equal to 26x. Divide both sides by 26, and I'll get negative 29 over 26 is equal to x. Okay, the next example, I'm going to multiply by 15. Okay, 5 goes into 15 3 times. 3 times 2 is 6. And then 3 goes into 15 5 times. Notice the 1 minus x. Because it has two items, this is called a binomial. We have to put in parentheses. We can't just write 1 minus x. So if the numerator has more than one item in it, you have to put it in parentheses. So then I'm going to continue. 15 times 1 is 15. Okay, the next one is being negative, and then 2x minus 1. Okay, again, 2x minus 1 is a binomial, so I put it in parentheses. Okay, so now I'm going to distribute. I'm going to combine like terms. I'm going to bring over the 2x, bring over the 10. Running out of room, 13x is going to be negative 9. Divide both sides by 13, and x will be negative 9 over 13. Okay, the next example, I'm going to distribute the 2 before I multiply by the LCM. So I'll get 2x plus 2/3. Okay, so now I'm going to multiply by 3, which is the LCM. We get 6x plus 2 equals x plus 1. I'm not going to put the x plus 1 in parentheses here because there's nothing in front of it, but if you want to, you can. It's just not necessary here like it was in the previous example. So I'm going to subtract x on both sides and then subtract 2. We get 5x is equal to negative 1, and then x will be negative 1/5. Okay, the next one I'm going to multiply by 10. And the first one would be negative 6x, then 5x plus 10, and then 2x plus 1. Again, I don't need to put 2x plus 1 in parentheses because there's nothing with it. Okay, so this will be negative 11x. Don't know why my color changed, but it did. And then I'm going to add 11x on both sides, subtract 1. We get 9 equals 13x, divide both sides by 13, and so x will be 9 over 13. Okay, so the next lesson is called a literal equation, because you're going to solve for a variable, but your answer is also going to have other variables in it, so that's why it's called a literal equation. And this expression, express x in terms of a, means solve for x. So in terms of a just means that there are two variables, one x and an a. So I have the answer posted here that's directly from your textbook. So I'm going to take the equation, and what I'm going to do is I'm going to put an arrow over the variable x, so I know that's what I'm solving for. It's not going to always be x. So if this said like express b in terms of a, then you would be solving for b. So be careful with that. Okay, so I'm going to, since I'm solving for x, I want to bring it to on one side. So I'm going to bring over the smaller term. And then what I'm going to do is I'm going to add 5a to both sides as well. And what that's going to do is that's going to get rid of these. And I'll have 17x is equal to 5a plus 4. Now, remember, order is very important, so don't write 4 plus 5a. Then I'm going to divide by 17, and I'm going to divide separately. And so x is equal to 5a over 17 plus 4 over 17. Now, if you look at the answer, they divided everything by 17, and that's totally fine for this type of example. But please be aware. Let's just pretend that at this step with the star, I got 4. So I'm going to put in a little bubble here. This is me pretending. Let's say there was 4x equals 5a plus 4. Let's just pretend that was the answer, or that was that step. If I divide by 4 like this, and I get this as my answer, I'm going to take off 1 point for that. Because guess what? These 4s, they reduce. So if you notice, when I taught this problem a few seconds ago, I said to divide separately. So watch what happens when I divide separately. So that would be x equals 5a over 4 plus 1. Notice I reduced the 4 and 4. So what I suggest doing is following my suggestions, which is to divide separately always. Because if you don't, you probably will forget to reduce and you will have points taken off for that. Okay, so I'm solving for x again. So I'm going to bring over the smaller term, bring everything else on the other side. And I'm going to have 5x equals 2a minus 1. Divide separately by 5. Nothing reduces, but again, it's just good form to divide separately. Okay, try these examples. I'm going to distribute first before I forget. Then I'm going to draw an arrow over x before I forget that's what I'm solving for. And then I'm going to bring the smaller x over, bring everything else to the other side. And this will be 5x on the left, and this will be 2a minus 8. I think you can kind of see I've been crossing things out. So you should cross those out. I'm kind of leaving them bare like that so you can see the work easier. Then we're going to divide by 5, separately, of course. And then this will be our answer. Okay, and again, this is just weird because it's called a literal equation. You're left with a variable in your answer even though you're solving for another one. Okay, so the next one, I'm definitely using the LCM trick here. And 3 goes into 6 2 times. X minus 2a goes in parentheses because it's a binomial, or it's because it has 2 terms. 6 goes into 6 once, so that's just going to be x. A times 6, and then 1 times 6. Okay, I'm going to distribute now. I really like the LCM trick. It gets rid of the fractions every time. If you're using the LCM trick and it doesn't get rid of the fractions, either your LCM's wrong or your calculation was wrong. So, all right, so what am I solving for? So I'm solving for x. I'm going to bring it over to the left, and I'm going to bring the 4a over on the right. And that's going to be x equals 10a plus 6, and that's it. I didn't have to divide anything. Okay, so this is the same lesson, but they just changed the variable to solve y in terms of x. I'm going to start right away by using the LCM trick. So it's going to be 6x plus 3y equals negative 6 plus 4x. I'm solving for y now, and so that means I'm going to bring over this 6x. Divide separately by 2. This is a perfect example where we're dividing separately. I think I'm going to run out of room, so let me put my answer here. So y equals negative 2 minus 2x over 3. So yeah, if you divided everything by 3, you might have forgotten to reduce. Just so you are aware, 2x over 3 is the same as 2/3 x. So just so you're aware. All right, so the next one, I'm going to multiply by 6 again. Okay, and I'm solving for y, so I have to subtract 6y, and then subtract 12x. Okay, so I'm left with 3y equals, now, because order matters, I'm going to do the x's first and get negative 2x, and then 24 I'm going to write last. Don't write 24 minus 2x. Order is important. So I'm going to divide both sides by 3 separately, and then y equals negative 2/3 x. So I'm going to pull the x in the middle. Remember, it's the same if it's in the numerator, and that reduces to 8. Okay, try these examples on your own. So 3x plus 2x minus 2y equals y plus 4x plus 1. I'm solving for y. Before I start bringing over terms, I need to combine like terms. And I'm going to add 2y to keep my y positive, but you don't have to. Then I'm going to subtract 4x to bring it on the other side and subtract 1. So I'm going to do this in order. 5x minus 4x is 1x minus 1. This goes to 0. These are 0 too. And then that's going to be 3y. Divide everything by 3 separately. X over 3 minus 1 over 3 equals y. If you, in the beginning, subtracted y on both sides, at this step right here where I added 2y, you would have had the y on the left side, and you would have gotten the same answer. So the next one, let's see, how should we do this? Okay, so I'm gonna not distribute the half, because I think that's gonna be a little more work. Watch what happens when I don't. So 3 goes into 6 2 times, 2 goes into 3. Okay, so this half is going to go multiply with the 6, right, and get 3. And then what I'm going to do is I'm going to just copy everything in the parentheses. So I didn't have to distribute the half. Sometimes it's best to distribute, and sometimes it's not. But if you do distribute the half, you'll get the same answer. It's just more work. You're just doing more work. Okay, so distributing the 3 now. And I'm solving for y. So let's do it the other way in case you guys don't like bringing over the smaller term. Because if let's say I bring over the larger term, you'll see right away I'll get a negative. But the answer will be the same. So I'm going to bring over the 2x. And so I'll get negative 3y equals x minus 4. And then divide by negative 3. So if you already don't like the negative that's happening, which I think some of you may not like it, do it my way, bring over the smaller term. But it's up to you. Answer will still be the same.